They had been told for decades that the mesa held more than stone. Old rumors spoke of tunnels, chambers, and the occasional whisper of a craft slipping into rock as if the basalt could breathe. But rumors rarely come with instruments, and instruments rarely return mysteries. What changed on Skinwalker Ranch was not the appetite for mystery, but the discipline to surround it with sensors, timing, and corroboration to let anomalies collide with method. The team's focus on the mesa and the triangle was not superstition, it was pattern recognition. Instruments failed there, telemetry bent there, rockets bent there. And on a night that should have yielded only noise, a camera slowed reality enough to catch something the naked eye never could. A luminous, blob-like presence hanging no higher than a two-story house above the launch pad, appearing in the very instant a rocket detonated mid-flight. The rocket hits it and explodes. Someone said, stunned, trying to keep their mind from leaping to the simplest but most unsettling conclusion. If the sky can hide structures, then space above this ranch is not empty, but occupied, layered, active Turn 1 file, 0YL29, L35. Turn 1 file, 0YL15, L23. The mesa, though, is where the hypothesis of hidden technology becomes tactile. Ground-penetrating radar GPR is unforgiving to unfounded belief. It returns reflections, not visions. So when a world-class operator scanned the ridge and pulled back a cross-section, the dataset yielded a vertical feature so tall it matched the mesa's height about 40 meters deep with a lateral width on the order of 6-7 meters. It was unique across hundreds of meters of survey lines, and it lay coincident with a prior drill site that had already produced metallic fragments whose composition and texture did not fit weathered geology. The operator could not label it, only underline it highly anomalous, as if the subsurface had grown a pillar you'd expect in an engineered shaft, not a natural slope. The team's own synthesis was boulder iron-bearing material with exotic trace signatures, tellurium, europium, a dome-shaped structure resistant to directional drilling, and a vertical void or structure adjacent to it. Taken together, the picture looked less like random geology and more like architecture intentional disposition of material beneath an ancient pile of rock. Turn 1 file 3AL7L17, Turn 1 file 3AL23L31. Hidden technology is a large claim, but the line of reasoning here does not begin with saucers. It begins with constraints. Consider first that multiple attempts to interrogate the mesa with GPR faced interference uncharacteristic of the instrument's long history. The technician who had just tested his system that morning watched its expected waveform mutate into an unusable checkerboard over the drill site data salvageable only in scraps. Where did the interference originate? If it were purely external RF, its behavior should be tractable. But the stronger suggestion, one the team could not rule out, is that emission sources lie within the mesa itself, generating or re-radiating signals that drown the radar in place while leaving the system healthy elsewhere. The practical consequence is crucial. The precise spot where directional drilling bumped an impenetrable layer is also where radar becomes confused. If you were trying to hide a vault, you might not rely on concrete alone. You would rely on the physics of energy coupling, making probing itself part of the alarm system. Second, consider the recurring 1.6 gigahertz signature. This is not a one-off spike at some random time. It correlates with operations digging, drilling, crane movement above the suspected structure, and it appears and vanishes as if excited by interaction like a resonant system being tickled at just the right frequency. During crane operations to peel back boulders near the anomaly, the spectrum analyzer lit at 6 gigahertz, then quieted when the crane paused, as if the crane-mesa pair briefly formed an unintended antenna or waveguide energizing a hidden transmitter or cavity and letting its emissions leak just enough to be caught. The team's question was simple and direct. Where is the energy source? If the signal strengthens with heavy metallic structures positioned above the suspected dome, the simplest coupling model says the source lies below, not in the Sky Turny File RJ, L19, L27. Now place those two strands next to the triangle events. The high-speed camera's 1,000 frames per second scrutiny, tuned to catch transient physics, documented a luminous stationary feature that was not present moments earlier, blooming in brightness as the rocket's own light washed over the scene. The explosion occurred at the precise altitude where that feature manifested in the 30-40 foot band, reprising an earlier year's failure in almost the same vertical slice of air. If a rocket's vector reliably bends or fails where no tower cable or meteorological shear is recorded, you are left with either a coincident mechanical defect across disparate systems or a repeatable spatial anomaly with physical extent. The latter would mean the air is not homogeneous above the triangle. In some windows, it is structured perhaps a boundary layer, perhaps a field gradient, perhaps a thin persistent membrane whose optical signature is elusive at real-time frame rates, but not at microsecond. Scales. Turn 1 file 0YL L15, L23. Turn 1 file 0YL L17, L21. Interrogate the failure mode. The motor did not burn through the expected nozzle path. It deflagrated sideways, an abnormality even veteran rocketeers had never seen in off-the-shelf motors. If you put aside romantic explanations, you might attribute this to a casing flaw, but the photographic sequence challenges that comfort. A bright spot appears above the mesa for a millisecond, then the rocket's plume clears as a shock wave radiates from the detonation as if combustion energetics suddenly redistributed, not because the motor decided to fail randomly, but because something in the rocket's environment acted upon it right where that blob held station. Stack this against the telemetry earlier. Rockets and GPS instruments had been seen to veer as though encountering an invisible refractive layer that nudged their trajectories off course. A force field. The phrase feels comic book, but in physics, force fields simply mean regions where potential gradients exist: electric, magnetic, gravitational, exotic. A refractive index gradient in ionized air, for example, can deflect EM and perhaps contribute to unstable combustion. A dense pocket of charged particles could interact with electronics. A shear in a vector field could torque a body. What matters is not naming the field, but acknowledging the consistent phenomenology repeatable spatial behavior in a defined volume above a defined patch of ground. Turn 1 file 0YK L11, L19, turn 1 file 0YK L21, L25. Then there were watchers. The same night that the high-speed camera gave the first clean look at a skyborne anomaly, a helicopter entered the ranch's airspace and went dark. No ADS-B transponder signal, no friendly broadcast. It hovered, orbited, returned like a platform profiling a target, and it did so minutes after the failure as if on cue. The team system pulled in other aircraft out to 100+ miles, proof the receiver was functional, yet nothing appeared above them. If it was not commercial, and if it flew at night in that terrain with apparent night vision capability, the range of operators narrows. The legalities were not the issue. The timing was. Who arrives within minutes of an anomalous rocket event unless they were already nearby or already tracking the operation? The psychology of surveillance is a poor reference class for physics, but the presence of a platform that behaves like a reconnaissance asset at the very moment your instruments register novelties is an epistemic multiplier. It says that whatever you touched is interesting enough to someone else to watch you touch it again. Turn 1 file 1L L9, L17, turn 1 file 41 L7 L15. These overlays subsurface anomalies that look engineered an RF line that wakes under mechanical coupling low-altitude sky, features collocated with explosive failure, and transient watchers become far more than the sum of their parts. They suggest a system. A conservative model would be terrestrial, a buried structure of unknown vintage metallic and stratified hosting cavities that act like resonators or waveguides at L-band frequencies. Above it, the air column supports periodic energy phenomena intense enough to scramble GPS, deflect trajectories, and seed combustion instabilities. When the site is excited by drilling by cranes by rockets, the system emits, and watchers whose job is to monitor such emissions arrive to sample. This model requires no aliens. It requires an undisclosed installation with sophisticated RF behavior, a Cold War remnant, a test bed. But the history of the property, the bulwark of indigenous lore around portals, and most of all, the aerodynamic footprints of UAP observed with and without ADS-B correlates widen the parameter space to include non-terrestrial or at least non-public technology. That widening is not just narrative, it is data-driven. Consider the daylight UAP captured near Brandon's helicopter during a later experiment. By applying contrast filters to ground-level footage, the team isolated a compact reflective object pacing the aircraft, a solid metallic-like body with glints comparable to the helicopter's own specular flashes. This is not a compression artifact. The highlight behaves like a physical surface catching Sunday. The context matters in the same window. The helicopter's GPS logging went haywire sketching, impossible vertical loops and lateral excursions. The pilot did not fly while on the ground. The 1.6 gigahertz line was again in play, and a air-sensitive crew member reported sudden head and neck pain phenomena on the ranch has long associated with active periods. The cluster RF physiology GPS UAP recurs too often to dismiss. If a single technology can account for all four in tight temporal proximity, it would likely be a system that manipulates EM fields in ways that intersect with navigation, biology, and propulsion. Precisely what advanced aerospace, beyond our current public inventory, would do. Turn 1 file, 2Y, L19, L27. Return to the MESA. The strongest case for hidden technology is not the single spectacular vertical anomaly. It is the convergence of physical resistance, exotic material, recovery, and survey uniqueness. Directional drilling should have curved upward. It did not, halting against a hard disk layer. Later scans mapped a 20-foot wide, 120-foot tall anomaly immediately behind the suspect dome. Across 300 meters of GPR lines, nothing else like it appeared. When previous drilling extracted metallic flakes, their properties drew comparisons to high-temperature thermal protection, not in the sense of perfect matches, but in the sense of an engineered laminate rather than a sedimentary accident. And when machines approached the sky above, sometimes responded the way a system would if its subsurface components coupled energy into the air column under the right boundary conditions. Turn 1 file, 3ALL. 9L17, turn 1 file, 3AAL, 23L31. Suppose then there is buried technology non-human in origin or human but off catalog, whose outer shell resembles a dome and whose internal shafts or bays create the tall, narrow return. Suppose further that this system is intentionally difficult to penetrate not just by mechanical strength, but by field effects that degrade probes, jam radar, and throw off navigation. Such a system might be asleep by default waking, when massed metal above it resonates at the right modes, or when rocket exhaust and RF harmonics light the local plasma. The 1.6 gigahertz line would then be an address, a beacon, or a byproduct communication or control. The low-altitude blob could be a local field gradient, a thin interface, where parameters change a kind of boundary layer that is invisible until lit by a luminous source, and then snaps out of existence when the excitation ends. In wormhole language, skeptics roll their eyes. In field theory, interfaces are mundane, and the question becomes whether the gradients you need can be sustained in air at those scales. The answer is not impossible. If the buried structure is powerful, if it stores energy, or more subtly, if it shapes background energy, then releases it in narrow bands, you need only consider how little we currently see of the EM environment in real time. Most of our sensors are not designed to catch millisecond interfaces in a 30-foot box 10 meters above ground. Human watchers do not prove alien builders, but they do indicate stakes. When a helicopter without ADS-B orbits your site immediately after you trigger a unique event over an already notorious ranch, you are not the only stakeholder in the anomaly. It is not surprising that state officials took interest. What is surprising is the blasé no comment on a Black Hawk track inferred from independent contacts. The team's own logs show the practical implications. If orbital surveillance assets are cued by RF emissions or optical transients, then any repeat experiment that energizes the system may bring company again. That imposes operational security constraints on a scientific project, and hence, if one is inclined to infer that others know enough about the site to stage assets within response range whenever interesting physics is, likely turn 1 file 1EL21L27, turn 1 file 2ELE1L7. From a methodological standpoint, the most persuasive path to hidden technology is to trap the system in a corner of parameter space where its behavior is most constrained. On Skinwalker Ranch, that corner appears to be a triad subsurface coupling cranes, divided by drilling low-altitude photometry, high-speed cameras, and synchronized IR and L-band spectral monitoring. The nights with the richest events combine all three, and when they do, the narrative keeps closing on the same coordinates, the triangle column and the toe of the mesa. The team's plan to segment boulders, stabilize a pad, and bring in a drill rig aligned with the GPR inferred shaft is not merely curiosity, it is the forward edge of a test that could collapse dozens of competing explanations. If the drill returns engineered laminates, layered alloys, anomalous crystalline phases, manufactured ceramics, then hidden technology graduates from inference to inventory. If instead the drill returns geology and nothing more but the RF signatures and aerial anomalies continue to correlate with operations, then the technology may be less object and more field, a buried natural cavity acting like a maser or an unknown geophysical battery. But that hypothesis is already strained by the directional drilling resistance, the uniqueness of the return, and the properties of recovered fragments. Turn 1 file 3L, 21L29. Turn 1 file 3L, 31L33. Finally, there is the human variable, the way the ranch responds to people differently, as one witness put it. When Thomas, who has a history of adverse effects at the site, abruptly developed acute symptoms during a triangle overflight, the event coincided with the 1.6 gigahertz signature and with flight control and GPS oddities. If a field couples to biology in a way that is sensitive to individual physiology, you have another keystone of advanced systems selective interaction. A device that manipulates space-time at small scales, or even merely sculpts EM fields in complex time-varying geometries, might expose nearby observers to gradients or transients their bodies interpret as distress. That is not proof of alien craft. It is proof that whatever hides here hides with enough power to touch both machines and minds in the same minute. Turn 1 file, 2IL, 19L, 27. The Mesa's story is thus not one of myth layered on myth. It is one of signals layered on structure. A 120-foot-tall anomaly adjacent to a resistant dome. Metallic flakes suggestive of high-temperature design, radar that fails where it should thrive, a spectral line that wakes when metal meets rock. Rockets that die exactly where a camera finds a luminous stationary feature. Watchers who arrive on a schedule written by physics, not by chance. If you were asked to draw an evidence-based picture of hidden technology, this is the sketch you would produce. And if you were asked what kind, human or other, you would be forced at minimum to admit that either answer changes our understanding of the place. If human, then, a clandestine engineering achievement with field effects still poorly understood, has slumbered beneath Utah's desert long enough to be mistaken for myth, and the watchers are its custodians. If other, then, the ranch is not merely a site of sightings, but a site of contact with infrastructure, hardware embedded in geology, emitting on demand, interacting with air and light and combustion, and perhaps under the right excitations, opening interfaces we can finally begin to see. For now, the Mesa does not yield names. It yields coordinates, depths, widths, and timings, and those are the currency of real discovery. Follow them, and technology hidden, yes, but no longer silent, will either deny itself or let you in. Until then, the most honest sentence is also the most provocative. There is something engineered in or under that rock, and when you touch it, the sky answers. Turn 1 file 0YL 29L35. Turn 1 file 3YL 9L17.